Hello everyone. In this video, we'll be presenting our milestone for the final project named What's Cookin'. It is basically a recommendation engine for recipes to cook. I am pretty sure all of us would have gone through the daily struggle of deciding what to cook for the day. We, being enthusiasts of trying different food dishes, decided to build a food recommendation engine that can help people decide the next meal. This will help people explore various dishes cooked worldwide. We intend to build a food recommendation system that suggests dishes based on similarities of food items and also ratings of users with similar interests. Now let me say why is it more challenging for us. The major challenges would include collection of data from multiple websites, and it should be structured appropriately. Datasets should be thoroughly explored to identify features. We have to choose an appropriate model to group similar users or food recipes together. In addition, we need suitable visualizations and an interface to show recommendations. Till date, we have worked on the following components of the project, namely data collection, exploration, and model training. In data collection, we started our project by gathering data using web scraping from various food recipe aggregator websites. After cleaning the data, we were able to obtain information like ingredients, reviews, ratings, nutrients, and directions to cook about the recipe.
We can now look at data exploration. We have performed several exploratory data analysis over the data and understood relationships and correlations between various features in the dataset. Let's consider an example. We explored correlation between various nutrients and the corresponding ratings given to the recipe. So this gives us an insight into how the ratings are influenced by the ingredients. Next, we can look at model training. To enhance and add cuisines to our features, we built a support vector classifier. Our initial idea was to implement a deep learning model to predict the rating that a user might give to unseen food dishes and recommend them based on a ranking. However, we realized that the lack of data for a new user might cause such an approach to fail, leading us to consider more traditional approaches for recommendations, including content-based recommendation systems to find similar items and collaborative recommender systems for similar user activity. We are currently exploring various machine learning models like K-means model for item-to-item recommendation based on ingredients and RBM, that is restricted Boltzmann machine, for user-to-user recommendation based on ratings. Next, we can look at the Git repository commits for. So this shows us the history of our repository commits to Git for our project. Let's now look at the schedule. Following is the schedule we have derived for our project. We plan to focus on our model engineering for the next several days and then begin on the subsequent steps. Let's now look at our future work. So alongside the model selection practices, we'll be focusing on integrating data from various sources to create one single data source for the model to intake. Then we plan to explore more on recommendation evaluation metrics. As well as, in order to present our system to end users, we plan to develop an interactive UI on the successful completion of the recommendation. Next, we can look at our risks. Some of the risks we foresee are duplication in integrating different datasets. This can be resolved through entity resolution. Another risk that we foresee is that for item-based recommendations, there is a potential risk of increasing dimensionality. So this can be handled with appropriate feature selection and dimensionality reduction methods. Thanks for your time. Cheers and happy cooking.